Hello, welcome to another video. And in this video we're going to be looking at the graphical relationship between f prime and f double prime. So let's get started, and probably the most important out of these three is f prime. And so you guys have probably already covered the definition, the mathematical definition of a derivative, but what I'm going to talk about in this video is mostly intuitive and graphical. So let's take that look at the derivative. So we have a graph here, and this is a tangent line. Well, technically it's a secant line, but as you know, if you're to drag this point B over to point A, then your line will be a better approximation of the tangent line. But anyways, what I want to focus on here is if I've got this guy, he's happy and he's hiking up this this slope here. And so we can say that if he's going uphill, then the first derivative is positive. But if he was going downhill, then the first derivative is negative, right? And so I'll draw another example of that maybe over here, where this time he's going down, and in that case the derivative would be negative. And now if at one point he's kind of on flat ground, right here he's walking on flat ground, then you could say that the derivative is 0 at that point. And why we're talking about this guy going up a slope and all is just so that you guys have a easier time graphically identifying the sign of f prime, because it's one thing to do it in the math, but it's a whole other thing to do it on these graphs. And the AP exam is very fond of using these graphs and having you connect between the graphs and the math, so to speak. So with this in mind, we can look at the different representations of what it means for the sign of f prime to be either positive or negative. And all the things that I'm going to list right now are going to apply only to the graph of f. They may not necessarily apply to, for example, f double prime. So just keep that in mind. So we can say the graph moves up and down, right? Another word for that, increases, decreases. Like, for example, if how I've written this is like, if the first derivative is negative, then we're moving down and we're decreasing, and so on. And we can also say walking uphill, downhill, right, like we just talked about, or the tangent line has plus minus slope. So this might just be a review for you, but it's important to keep all of these different graphical representations in mind when now we're going to be talking about the sign of f double prime. So what does it tell us about the graph of f prime? Well, f double prime, it's quite literally just the derivative of f prime, right? That's how we find f double prime. And so the graph of f prime will have the same sort of relationship with f double prime as regular f did with f prime, right? In general, right, a function's derivative tells you all of these things. A function, right? F, it could be just f, or it could be some f prime, but either way, a function's derivative gives you all of this information. But perhaps more interestingly, we can talk about the graph of f. What does the sign of f double prime tell us about the graph of f? Well, one way we could think about this, right, is if we've got this guy on this slope here, and suppose that you took this point of the slope and you, as he was walking along, you kind of pulled this with a force. You pulled that down. You pulled the slope down. So he's hiking more downhill, so to speak. And this example over here is a good example of that, right? Because over here, toward the left, we see that he's walking very much uphill, but we've got this this kind of pulling, this pulling of the slope, and now he's flat, and he continues going downhill, right? Because the slope is being pulled downward. And in this case, if we're being pulled, I'm using this very loosely here, pulled downward, you can say that the second derivative is less than 0. Now this is, of course, all of this is assuming that we are talking about the graph of f, y equals f of x, right? If this is f prime x, right, then it's a different story. But I'd just like to focus on f right now. And likewise, if the graph of f is pulled up, right, then you can say that the second derivative is positive. And that would look something like this, right? Because now he's going uphill and he's being pulled up, and now he's going downhill and he's going uphill. And so we can summarize this by basically saying pulled up or down, right? And one thing I'd like to mention here, right, this pull, right? If you're taking AP Physics, you know that one of Newton's laws is this, right? But what is A? What is acceleration? Well, that's really the second derivative of position, right? If you might see it like this too. Same thing, right? And so really, when it comes down to it, if we solve for acceleration here in this equation, you can kind of see that accelerations are almost forces, right? I mean, without this m, it's just a scalar in the way. But what Newton's law tells you is that you can conceptualize the second derivative as a force, right? And so this f is not some sort of wishy-washy thing that I'm saying to make it all make sense. You know, it also reflects what's going on physically. Like, for example, suppose that now you're not talking about a person walking up a hill, but now maybe this is the position of a ball after you threw it up. And so now this arrow means something. It's gravity, right? It's gravity pulling it down. And so you get the same effect, right? You get the same concave down effect because gravity is pulling it downward. So when we later apply these concepts to optimization and all these cool things, you're going to really need to have these basic understanding of f prime, and f double prime solid so that we can continue on with optimization. Well, that's it for this video. I'll see you guys in the next one. We'll be talking about local and absolute extrema. And yeah, thank you.